This is Mr. Hassan's Maths channel, and I'm now answering question number 3 from the Solomon I paper this is from Pure Mathematics P3, and I'm also, this question is part of my end of topic worksheet that I have made for my Cambridge, and I guess it's also for my Excel collection for differentiation 1. Both of these would be in P3 of Cambridge and P3 of Excel as well, so it's relevant to both of those. And here we have the first question is about the function f of x, which is defined as x squared plus 3 over 4x plus 1, where x is all real numbers except for negative a quarter, for obvious reasons, because that will cause the denominator to become 0. We have to find and simplify an expression for f dash of x. Now, one of the things that students mix up is f dash of x, which is basically when you have to find the derivative or differentiate f of x, and f to the power of minus 1x, which is the inverse. Okay, we're not finding the inverse. Many students actually make this mistake where they mix up finding the inverse and finding the derivative. So they would go out trying to find the inverse of this function and of course lose all the marks, right? Okay, so here they're asking us to find the derivative, differentiate this. Okay, so find it and simplify an expression for f dash of x. So here we have a quotient of two separate terms. Two terms, numerator and denominator. What we cannot do, like some students try to do, especially when they first learn about these topics like product and quotient rule, is we cannot just differentiate the numerator and the denominator separately and then just write the answer. I can't just say, oh, that's 2x over 4, for example. I can't do that. But for multiplication and division, you can't just differentiate a product and the other part of the product and then just multiply the two answers together. You have to use the product rule. In this case, we have to use what's called the quotient rule. Okay, we have a quotient of two terms. Okay, so what we do is, for the quotient rule, you must call the numerator u, so that's going to be x squared plus 3, and you must call the denominator v, so that's going to be 4x plus 1. And then you find the derivative of the numerator, so that's u dash, that's going to give you 2x, just 2x, because the 3 becomes 0, the constant when you differentiate becomes 0. And 4x just becomes 4. Okay, now when we use the quotient rule, what we do is we multiply v by u dash. So I'm going to do that. That's going to be 2x. So I can say f dash of x is going to be equal to, that's 2x times 4x plus 1. And then you take away the product of these two terms. So it's v dash times u. So it's x squared plus 3 times 4. So 4 times x squared plus 3. Don't forget there's a minus between them. And then you divide by v squared, which is 4x plus 1 all squared. Okay, so you must always start from the v. So it's v times u dash, this diagonal, minus u times v dash. Okay, now we're going to simplify. So let's just simplify this. So f dash of x is going to be 2x times 4x, which is 8x squared, plus 2x minus 4x squared, and minus 12, all of that over 4x plus 1 all squared. No need to expand this. And then finally we can write the simplified answer. F dash of x is equal to 8x squared minus 4x squared is going to be 4x squared, and you got plus 2x and you got minus 12, all of that over 4x plus 1 squared. Okay, so there's the answer to part A, where we just find the derivative. Now for part B, it says find the set of values of x for which f of x is increasing. Okay, now, so the set of values of f of x for which f of x is increasing is basically the values for which the curve is going upwards, which means, okay, you can say f of x is increasing. It's going to be increasing when its gradient is greater than 0. If f dash of x is greater than 0. Now, some schools of thought will also say if f dash of x is greater than or equal to 0. Okay, they include the equal sign. Okay, between these 2 points it's increasing because the gradient is higher there than it was there. So the whole time it's been increasing. I mean, I personally like to write it like this. Now, in the answer scheme, it's written with an equal sign, okay, in the mark scheme of this paper, okay, which is a Solomon paper. But I prefer to write it without the equal sign. This is called a strict inequality, and this is non-strict, okay? So I prefer to say, all right, it's increasing when the gradient is positive. When the gradient is 0, it's like horizontal, but because it's just a point, it's not such a big deal. So either this or this is fine. I personally will stick to this. Even if the mark scheme says something different, they will accept both non-strict and strict inequality. So you can write, for me, it makes sense. It's increasing when the gradient is greater than 0. So I'm going to say when f dash of x is greater than 0. Now we already found f dash of x. So we've got to basically solve the equation 4x squared plus 2x minus 12 over 4x plus 1 squared is greater than 0. Okay, now to solve this equation or this inequality first, to solve this inequality, what we have to do is we have to get rid of the fraction. Okay, that's one way you can think about it. So, okay, we need to multiply both sides by 4x plus 1 all squared. Now, multiplying by a variable is a problem with inequalities, because if it's a negative answer, if it's a negative number you have to multiply by, the inequality sign must change directions. Okay, if you multiply both sides of an inequality by a negative number, the inequality must change its direction, the sign. Okay, it must change its direction. So if you're multiplying by a variable and you don't know, or there are some values of x for which that variable can be negative and some that can be positive, then that's a problem. It causes a problem in our answer. However, 4x plus 1 all squared, 4x plus 1 all squared will always be greater than or equal to 0. So there's no problem with us multiplying by this because it will never be multiplying by a negative number. Another way you can think about it is if 4x squared plus 2x minus 12 over 4x plus 1 all squared is greater than 0, well, this is always going to be positive, okay, because whatever goes in there, you square it. Therefore, this must also be positive because, you have a positive divided by positive will give you something greater than 0. All right, so we could say, all right, that means 4x squared plus 2x minus 12 has to be greater than 0 as well. Okay, if this is true, then this is true as well. Now we can solve this inequality. Our question will be answered when we solve this inequality, this quadratic inequality. So what we're going to do first, we're going to find what are called the critical values. So I'm going to try to find the values where 4x squared plus 2x minus 12 equals 0. This takes us back to the work from AS Maths, basically. So to solve this quadratic equation, I've got to find two numbers that are multiplied to give us negative. Well, what I could do first, actually, before I do that, is I can make it easier. I can divide both sides by 2 to make this an easier inequality to solve. That's going to give you 2x squared plus x minus 6 equals 0. So I've got to find two numbers that multiply to give me negative 12x squared, and they add to give me plus 1. The sum is plus 1 or plus 1x. I think that's pretty easy. 4 and 3, right? 4 and 3. So you're going to have plus 4x and negative 3x. They will multiply to give me negative 12x squared and add to give me 1x. So I can take out the factor from these two terms here. Then I say 2x times x gives me 2x squared. 2x times plus 2 gives me 4x. And x times minus 3 gives me minus 3x. So we're left with 2x minus 3 and x plus 2 equals 0. So we have x equals minus 3 over 2 and x equals negative 2. So those are called the critical values. Now we want to find where the values are for which this is increasing. So we're going to draw this equation here. We're going to draw this. We see it's a quadratic. So I'm not actually drawing here the original equation. This is not the original equation I'm drawing. I'm drawing the gradient function, okay, or the part of the gradient function that I need to analyze to find out the values of x for which it's positive and negative, which is this part here. So when you draw this, okay, we know that it crosses the x-axis at minus 1.5 and at minus 2, and at plus 1.5 and at plus 1.5 and minus 2. My bad. Okay, so that's going to be a minus 2 here, minus 2 here, and 1.5 there. So it's going to have look like this, or go something like this, something like that. I haven't drawn it so well, but the important thing is to know where this is greater than 0. Okay, so we can see that this has a value which is greater than 0. Okay, greater than 0 from 1.5 onwards, and from -2 backwards. So when x is less than -2, when x is greater than 1.5, these are the set of values of x for which this is a increasing function, where the gradient is positive. So this represents actually f dash of x. This represents the value of the gradient of the function against x. And we can see the gradient of the value of the gradient of the function is going to be positive. It's going to give us a positive output when x is less than -2, and when x is greater than 1.5. So you can say f of x is increasing when x is less than -2, or when x is greater than 1.5. So there's the answer to this question number 7 from the worksheet, and question number 3 from the Solomon I paper. Okay, so that concludes this question. I hope that was clear. Other questions from this particular paper, from this Solomon I paper, can be found in the playlist over here. Other questions from this end-of-topic worksheet number 5 on differentiation can be found in the playlist over here. Okay, you can find my other differentiation questions from my Cambridge collection here and from my Edexcel collection there. Thank you for watching, and see you soon.